maybe I'll start with a quick question, and other panelists can also answer it. But one thing maybe we didn't get too explicit was talking about the time horizon of the future. What future are we looking at? When in the future? Because that's critical. And I know you guys think about it. It just didn't come up in the conversation up till now. So Amber, would you like to start there, and maybe you can go to the Fish and Wildlife folks?
Yeah, we really it depends on when the decision. So we only really use scenario planning in this approach when a decision is being made or for a planning process, and we look to the time frame that's relevant for that planning process. So for the example I gave for Wind Cave, that's a 5 to 15 year resource plan, and so we look about 30 years out in 2040 for those climate scenarios. But for some infrastructure work that we've done where they're investing millions of dollars in water infrastructure, they need that investment to last 7 years. And so we look to end of century projections. So it just varies.
Anybody else on the panel want to talk about that?
Let's say from Fish and Wildlife perspective, there are a few different things that we're thinking about. One being, what's a biologically meaningful time frame for the species? We need to be able to ideally capture multiple generations to have an idea of how these different factors are going to affect the species into the future. That's not always possible with long-lived species, but the other things that we're thinking about is how far out can we, kind of reliably predict land management actions or things like that, and then also how far out can we reliably predict climate.
Yeah, I would add, it's not an easy thing for us to determine what foreseeable future is, because, there's some specifics in the Endangered Species Act, that kind of define foreseeable future for us to extend. And I'll quote this: only so far into the future as the service can reasonably determine that both the future threats and the species response to those threats are likely. And I think the key word there is likely. But the devil's, at least in my opinion, the devil's in the details on that, because it's really difficult for us to determine what's likely, because a lot of times we don't have a very good grasp of what the species response will be. And so it's not an easy thing to determine. And it's really, in my experience with SSAs, it varies from species to species. That judgment call is made on a species by species basis, and it's not an easy decision to make on where to draw the line in terms of what that endpoint is. But we've generally been in kind of the, 30 to 50 year future time horizon. But we get pushback, particularly in the courts, that, why aren't you going out to 2100, and, why aren't you going out beyond? And so it's a delicate, I think it's a delicate balancing act is how I would put it. Because you have us on the science end, and we're saying, it's pretty tough for us, given all the uncertainty, to say that this impact is likely out to 2100. And I think a lot of us are more comfortable in that 30 to 50 year time horizon, and maybe not even very comfortable there, depending on the species. But increasingly, what I've seen is that there's a push for us and an argument from a lot of groups that we're not going out far enough. And there's no easy answer, in my opinion. But that's my opinion.
And that's interesting, John, to hear about that the tension or the push to kind of go further out. I feel like I've just in my observations with working with Amber and others at Park Service on their resource stewardship strategies. I think often the planning office, the planning division is doing these sort of what they call long range plans, which really we're talking on the scale of 10 years, 15 years out. And I've sometimes found we almost have the reverse, which is we're kind of looking maybe mid-century, and they're like, well, we're trying to plan for the next 5-10 years. And And we're like, well, that, I think often there's conversations around, encouraging thinking a bit further out to avoid, misinvestments or maladaptation, or, spending money on things for the next 5 years that will turn out to be sort of futile in the coming decades. So interesting to hear on the fish and wildlife perspective that in some cases you're getting pushed to go further out than you might be comfortable.
Yeah, thanks for those comments. I want to dig a little further into some of the things that came out. And John, you mentioned the word likely, and the word plausible came out earlier. Like part of scenario planning is exploring what is plausible or possible, and less so on what's probable. And so I think this tension between being likely and being plausible. And so maybe like to ask you to address those things as a panel. But I also want to throw one other thing is, you, like Amber showed, the participatory scenario planning that leads to assessment of, okay, we think that this kind of impact would happen in this future, in this climate future. How do we ensure that those are robust assessments, right? I mean, and so that goes back to this point of likelihood, like the part of the likelihood that comes out of maybe a little bit of a more robust understanding of the impacts and of the processes. So I'll leave it. I just put it out there to the panelists if there are further thoughts on that.
This is something that it's as much a communication challenge as anything, I think, of explaining. As scientists, we're all trained in estimating the likelihood of an outcome. But that can be difficult because we don't know which way it's going to go, which is why we use scenario planning. And so, at least for us talking with managers, the first step is always going in and explaining that we're not telling you the likely future, but we're presenting a range of all plausible futures, where all of these models that we're selecting from are models that are plausible representations of the future. And so by using those to bracket that full range of uncertainty, we're at least making decisions that are robust across those, or helping you make decisions that are robust across those. And it can be a challenge and requires constant reminder that we're not assessing which of these futures is the most likely. They all are plausible, so therefore should be considered equally, to make sure that you're not over leveraging one future and ending up with surprises. As far as what was the second question?
Ensuring the robustness of
of the scenarios. I mean, that's where, at least with the participatory approach, where the robustness is reliant on who's involved and who's in the room, and relying on their judgment to tell us if under this climate future, the drought that in 2002 caused prairie fires and these ecological responses, if you have that similar drought happening instead of once every 20 years, twice a decade, what will that mean for your resources on the ground? And it's imperfect, but it does at least help make decisions in light of that uncertainty and with that imperfect information. Yeah. And Brian may have more to add there.
Thanks, Amber. And I see John and Alex want to get in here too, so I'll keep it brief. But the only thing I'd add is that in some cases, this is, that's one of the reasons we've brought in sort of companion quantitative response modeling to go along with the participatory scenario planning work. They sort of have complementarities. So, for instance, in Badlands, we did some modeling of how prairie vegetation, sort of vegetation biomass and composition would respond to the same climate futures that we discussed in our workshop setting. Or I know at Wind Cave, Amy Simstad, who I see is here in the audience, and colleagues did hydrologic and ecological response modeling at Wind Cave to kind of validate, if you will, or sort of cross-check or provide some added detail to the scenarios developed in a participatory process. So I think a lot of good complementarity there, assuming you've got the resources, the staff, the time to do that kind of additional modeling, as well as the data. But I'll stop and let John or Alex or Amy jump in.
I was just going to add something super brief related to what Amber was sharing, and it's interesting to hear you. Exactly what you said, Amber, is what we have to remind decision makers during meetings when we're trying to decide whether to list a species or not, because the first question they always ask about the scenarios in our SSA is, which one is more likely? Which one can we use to make our decision? And we have to remind them, you can't choose one, you have to use all of them to make your decision, and consider that this presents a range of the possible futures for this species. And it's always like an hour-long back and forth of, but which one is more likely though? Or like, is this one less likely than that one though? Can you just tell me which one is like the most likely, even if you can't say the specific probability? And it's just really hard to get through that, because people really want to know the likelihood of future scenarios, which is something that we purposefully do not calculate or report.
Yeah, I was going to say the same thing, Alex. I think you hit the nail on the head, and I think the end product of what you just said is really, it comes down to the decision makers that are in the room, whether those are 2 or 3 different regional directors. It's up to their individual risk tolerance to try to make those calls. And they're, a lot of times they're not comfortable with it. And I understand why, and you can understand why they want to know which of those scenarios is most likely. And, we can't give them a good answer really, other than that they're all plausible. But, I think, and another plug for MTAS's paper, because I think it does a nice job of talking about compounding uncertainty. And when you're talking about foreseeable future and endpoints, you're talking about a lot of uncertainty, whether that's with the emission scenarios, but you have that uncertainty compounded on top of species response uncertainty, which is huge. And so, trying to communicate all of that in a decision meeting where they're trying to make a ESA call, as you can imagine, can be pretty intense, and there's a lot of information, and those are not easy meetings because of all of that stuff. And as all of you know, the devil's in the details. And anyway, I just wanted to say that, because the Alex is right. Decision makers always want to know which one of those is more likely, and you have to go into all of what I just said.
The only thing I'll add to that is I echo what all of you just said exactly. But the only thing that I'll add is that we do not determine which scenario is more likely than another, but from SSA to SSA, the robustness might be different. That, for some species, we might know they have this specific stream tolerance temperature threshold that is a level, reduces a little bit of that compounding uncertainty, where another species, we don't know what that temperature threshold is. So that compounding uncertainty can make us more confident in the analysis in one SSA over another, and those ones we're less confident in, those become increasingly difficult conversations, and having to say that, yes, here is the information that we're presenting you, but there is a lot of uncertainty here, and we just have to make sure that we're communicating that level of uncertainty.
Those are great points. Well, absolutely. I have, I can dig in further with that conversation, but I just wanted to, give somebody else a chance to ask a question at this point. We probably have a chance for one more question. Perhaps folks are, don't have a clear question right now, but perhaps I can just dig in a little further with that piece where you're talking about robustness amongst different SSAs. Also, John mentioned, knowing about the uncertainty with species sensitivity to climate. And so I mentioned earlier about, our limited understanding of the interaction between climate and the ecological biological response, something that we encounter over and over again as being a big limitation. So yeah, how do we reduce that limitation? What's like, can it be done fast, or this like 10 years, 20 years of research that what it will entail to kind of reduce that kind of limitation? But just wanted to throw it out there.
Well, one of the things that I from the science side that I find sometimes frustrating is that, we're supposed to rely on the best available science, and, there's really not a whole lot of room for, and I'll give you an example, like with southern white-tailed ptarmigan, we wanted to know, what their upper thermal tolerance was, and there was pretty good information on that. But what we didn't know is whether there was, what was the adaptation potential for birds in the southern part of the range? Was there any adaptation potential in those populations that experience hotter weather to adapt to that change, right? And, I see it time and time again, as if we just had little pots of money to actually throw at USGS or some other group to do really kind of small studies to help answer some of those really important species response questions, and to see if there is any plasticity in a population to actually be able to adapt to that kind of stuff, we would be able to have a much more robust future condition in our SSA. And in that case, we did actually get some money to give to USGS to do some of that work for ptarmigan, but that's an exception to the rule. Most times we don't get anything like that. So it kind of forces us to make our best judgment calls on what we think that might be. And that's where we lean really heavily on species experts from the states or from academia or whoever may be the expert group on that species in particular to get their opinion on what they think those impacts might be. But it's not easy.
Any other thoughts?
Yeah, I mean, I'll add that, really echoing everything John said, that this can be what's difficult. And, on the one end, we get expert judgment from subject matter experts or USG scientists or inventory and monitoring scientists out in the field in parks. And that's really good and useful information. What we really prefer, if we have the resources available, is to look at climate analogs and compare it to inventorying and monitoring data on the ground to assess those sensitivities and create a model where we can model out those responses in the future. But that takes time and resources that sometimes are available, and we're really just starting to scratch the surface of doing that in collaboration with that NPS inventorying and monitoring group. But that's where reliance on USGS and experts in the CASC are actually really helpful for helping us to do that.
Any burning thoughts, last burning thoughts here? We are at 11 at this point. And I want to just thank our panelists again for this very exciting session. And thank you all for participating, and hope to see you in other sessions this week.